So,
Noise.
guys, this is Hacktoberfest 2020. Hack Club NMIT is organizing it this year in collaboration with all the major partners that Hacktoberfest is having today, Disclosure, Dev, and Intel. So, Sayak, like if you can, before we start this, this amazing session on TensorFlow Hub models, if you can give a quick introduction about you, from where you came, that if you can just give a quick introduction about that, that will be really great.
Yeah, sure. So,
Yeah.
hello everyone. My name is Sayak. I work as a deep learning associate at an online education startup called PyMed Search. I have been a remote employee for about 2 years now, and my area of interest lies in self-supervised visual representation learning. Of the work, I like to contribute to open source initiatives like TensorFlow Hub and other ecosystems that are based out of TensorFlow. And of the work, I also like to write technical articles based on deep learning, and I like speaking at developer conferences and meetups like this. And when I'm not really working, I sort of binge watch stuff on Netflix. So yeah, that's about it.
Yeah. Sounds interesting. Thanks a lot. Yeah, we all love Netflix and developer conference all at once. So yeah, if you want to share some screen, I can stop my screen share and
Yeah,
like,
I would
okay,
like to share my screen. Yeah.
okay, cool. I'll stop the screen share, then we can proceed. Okay.
Okay, cool. Okay, let's get started. I'll just share my screen and we'll get started.
Meanwhile, guys, if you have any kind of questions, like you can raise your hand. If you want to have a one-on-one interaction, you can just, like our associates will gonna reach out to you via chat. You can just tell them either you want to have a one-on-one interaction, or you want to just, want us to read out your questions to Sayak. Both the things works. Just be active in the chat. We'll take the question side from there.
Could
Okay.
someone let me know if my screen is visible?
Yeah, it's visible, Sayak.
Okay, cool.
Okay then.
I'll just,
Over to you, man.
yeah,
Okay.
cool. Thanks.
Yeah.
Again, thanks again to NMIT Hack Club for having me here today. And I'm really excited to talk to you about uh, TensorFlow Hub, which is, well, okay, we'll see what TensorFlow Hub is because that's what the session is all about. So I specifically found this topic kind of interesting because we will be talking, because this entire day is sort of based around the theme of open source and stuff like that. So in a theme that's centered around open source, I would find TensorFlow Hub to be a highly relevant topic. Even PyTorch Hub or OpenCV Hub or Intel Model Zoo or something like that, I would find all of those topics to be highly relevant if we are going to talk about open source initiatives, specifically from a machine learning standpoint. So let's get started. Uh, yeah, so the ideal audience for this session would be machine learning developers that have worked with TensorFlow and Keras before, because as the name suggests, it's about TensorFlow. TensorFlow comes, TensorFlow precedes Hub, right? So you would want to have some knowledge about TensorFlow to be able to get the most out of this session. It won't work with PyTorch, or it won't work with Chainer or MXNet or all the other frameworks. So I would assume that most of you are into machine learning and most of you already know how to, create a simple model in probably Keras. So if you know that, you are good to go already. So just to be very clear, this session is not about an introduction to machine learning, or it's not about how to implement a cool fancy new rips paper in TensorFlow or something like that. This session is specifically about TensorFlow Hub. So yeah, first things first. So here's the agenda of the session. We'll be starting with what is TensorFlow Hub, because to keep things consistent, it's important that we start with the absolute basics. So I'll be introducing TensorFlow Hub for the folks that do not already know what TensorFlow Hub is, and then we'll discuss the usefulness of TensorFlow Hub or any any other similar initiatives like PyTorch Hub or OpenCV Model Zoo and so on. We'll then take a closer look at tfhub.dev, which is the online platform of TensorFlow Hub, and we'll then spend some time around discussing the ease of using TensorFlow Hub. And if time permits, we'll be having a question answer session as well. Okay. So what is TensorFlow Hub? That brings me to this question. So TensorFlow, I'm just gonna flat out read the official announcement posts. So please forgive me for that. So TensorFlow Hub is a collection of state-of-the-art pre-trained models published by different teams as well as community contributors. This means you will get to see models from organizations like Microsoft, DeepMind, Google, the teams at MLKit and so on. You will also get to see models from individual community contributors like yourself if you are interested. So that's about it. It's just a repository of state-of-the-art pre-trained models that are ready to use for a number of different tasks, and we'll see what kind of tasks the TensorFlow Hub models are typically good for. So why it might be useful? Because it's very important to lament on the usefulness factor of anything. So let's just get started with that. So here's the situation. Probably you have experience of training image classification models, and now you would like to step out of your comfort zone and you would like to finally be able to try out the ImageNet dataset, and you would want to pick a state-of-the-art architecture, and you would like to train the ImageNet. You would like to train that state-of-the-art architecture on the ImageNet dataset from scratch, right? The next question you would want to ask yourself is, do you have GPU access? I mean, having a single Tesla K80 or probably having a single P100 or V100 wouldn't work. Do you have access to typically, a cluster of GPUs to train such a model? Probably you won't have, because as students, it's probably very weird to expect that a student would have easy access to a cluster of GPUs. Even in universities like Stanford, it's not often the case. If you follow the CS231N lectures by Andre Karpathy, you would see that they also do not provide that kind of compute to their students. So probably if you are a student, if you would like to try out state-of-the-art architectures, and if you would like to train them from scratch on the ImageNet dataset, you would probably need access to a cluster of GPUs in order to train them, or at least TPUs or so on, right? So the entire objective of coming up with TensorFlow Hub in the first place can be summarized into these 3 points. The first point to me would be making state-of-the-art machine learning models more and more accessible, because as I had mentioned before, all the models that you would see on TensorFlow Hub that are pre-trained on the typical data sets, with respect to their different domains. For example, if we are talking about image classification, that is in the domain of computer vision, and you would typically get to see computer vision models trained on ImageNet dataset on TensorFlow Hub. Similarly, if you are dealing with NLP based tasks, you would see models pre-trained on probably the Wikipedia and similar kind of large data sets. So in that way, when you release these pre-trained models that are highly useful for a number of different downstream tasks, in that process, you eventually make the state-of-the-art, machine learning models more and more accessible to the wider public. So it also makes it really easier for people to take advantage of the state-of-the-art models without having much expertise in machine learning in the first place. Probably you are a web developer and Python to some extent, and you would like to try out this state-of-the-art pre-trained models, and TensorFlow Hub makes it extremely easy if you are willing to try some of these models out. So it has a very enriching user interface that allows you to do that, and we'll see how that might look like. So so in machine learning, there's this very popular concept of transfer learning, and I'm not going to describe what transfer learning is. So with TensorFlow Hub, you get to do transfer learning for a wide variety of different domains, including image, text, videos, audios, and so on. So to me, these 3 points are highly important. That would not only boost my productivity, but also it shed some light on the accessibility of the different state of the art models that are there, and that too they are coming from some of the best teams that are working on machine learning these days. But also it sort of provides the opportunity for us as individual contributors to contribute to the growth of accessibility and ease of using state of the art machine learning models at the same time. So these 3 points are highly useful, at least to me. So if you folks have any questions up till this point, feel free to ask away. If someone from the organizing team could see if there are any questions and let me know, I'll just answer them right away.
Okay, Aryan has just said, which is better for training a model, GPU or TPU? I guess that's the only question for now.
I would say it depends. It depends to what extent you would like to, expand your technical breadth. Because if you are willing to go for distributed training, no matter it's on a cluster of different TPU nodes, or no matter what cluster of GPUs you are using, you would need to know about some basic concepts related to distributed training. But if you have got access to TPUs already, you would want to prefer TPUs over GPUs, because they can boost the training time to a great extent, provided you have a very large data set, because TPUs are very data hungry. If you do not maintain a very flexible pipeline at which data is being continuously produced, and the TPU has enough time space in order to consume that. Otherwise, if your data pipeline is not that flexible, TPU would probably go underutilized. But at the same time, same thing would apply if you are operating with a cluster of GPUs. You would want to make sure that you have a very flexible pipeline that is able to continuously stream data to your model that is operating on a cluster of GPUs. But coming to your question, if you have TPUs and stuff, if you have a large enough data set, I would definitely prefer TPUs over GPUs. So I hope that answers your question. Okay, assuming I do not have any more question. So here's the final kind of point that's also important to me. TensorFlow Hub also provides us with a platform for developers to be able to give back to the community. As I had mentioned before, TensorFlow Hub exposes the platform to individual community contributors like us. So if you have trained a state-of-the-art model, and if you are willing to share that model with the community, TensorFlow Hub provides you with a very cool platform to share that and showcase that at the same time. Okay, so now I would like to I would like to present to you with a very brief demo of TensorFlow Hub. And TensorFlow Hub's online portal is tfhub.dev, and let's see, tfhub.dev. Yeah, let's go. So a couple of things to note here is, you see here we can search about different models, right? Let's say I want to search about efficient net. Let's see what comes. So I get efficient net, right? So it's efficient date. So it's another state-of-the-art object detection model, and probably due to some faults, it's not showing the architecture and the data set on which it was trained. But once that flaw is kind of resolved, it will show the primary architecture and the data set that this particular model uses. So it also has a corresponding open collab notebook that demonstrates the model usage, how you would use this model, and apply it on real world images and stuff. It also, of course, it provides you with a download link to directly download your model. But what is very exciting to me is this open collab notebook, because it directly allows us to try out that model without investing a single penny. I guess that's really cool. That's really cool. It also kind of provides you with a sample usage and all the necessary metadata that are needed in order to understand the model at a high level. And let's see, if you want to browse things with respect to model format, maybe you would like to specify the version of TensorFlow that was used in order to train these models. Maybe you would like to restrict the publishers and stuff like that, and maybe you'd like to restrict the data set and things. Maybe you'd like to restrict the language. Probably this is highly applicable to NLP based models. Maybe you'd like to specify the problem statement, image classification, feature extraction, or object detection, and so on. Maybe you'd like to go for architectures that are fine tunable in the first place. So all of these things are possible. Let's see if we have a cool model like CartoonGAN, which takes a natural scene image and cartoonizes it so that the visual, so that in a very visually appealing way. So let's see. Oh, we have a CartoonGAN model. Let's see. So this model was contributed by me. I'm not bragging myself off here, but I'm trying to prove the point that if you would like to contribute at an individual level, TensorFlow Hub does provide that opportunity for you too. So it essentially comes in the TensorFlow Lite format, but there are other formats that are supported as well. For example, the saved model format. If you would like to expose your model as a TensorFlow JS format, that's also possible. But currently this model is only supported in TensorFlow Lite format. So as you can see, I also provide a notebook that would allow you to try out this TF Lite model directly. Also I provide the download link, and here I describe the sort of expected outputs of this model and typical model usage and other notable things about this model. So one cool aspect that I like about TensorFlow Hub is if your model is already metadata populated, and metadata is one of the components of TensorFlow Lite, which makes it extremely easy for mobile developers to integrate a particular TensorFlow Lite model into their mobile application. So you can get to you get to see all of the nitty-gritty details about this particular TensorFlow Lite model, details about its pre-processing pipeline, details about details about its post-processing pipelines, and so on. What kind of images does this TensorFlow Lite model expect as its inputs, and so on. So all of these things are kind of included if you populate your TensorFlow Lite model with metadata like this. And metadata is only applicable for TensorFlow Lite models. So let's see another model. Let's say stylization. Okay. So yeah, Magenta, another subsidiary of Google that deals with creative machine learning and stuff like that. So it has this arbitrary image stylization model, and it comes in many different formats. As you can see, it comes as a TF Hub default format, which is the TF, which is the Hub module as they say it. Again, this model is 81.66 MB in size. It has also got a collab notebook in there. So this is the TensorFlow Lite variant of the model, and as you can see, this is only 4.49 MB, and it also has this open collab notebook tab if you would like to try out this model before you would incorporate this model in your applications. And it has also this cool import with Android Studio feature, but it does not allow you to directly incorporate the model in Android Studio. Probably that would be too much over optimistic, but it does takes you to the documentation that would walk you through the process of incorporating this particular model into your mobile application via the Android Studio. So yeah, I find it pretty cool. So again, as you would see, this model is also metadata populated. So TensorFlow JS models are also there, and you can just add a filter to see all the TensorFlow JS model that are out there. Let's see, problem domain. Okay, I first need to probably give some keywords and stuff. Audio, spice. Okay, let's see. So yeah, this model comes in the default TensorFlow saved model format, and it also has JavaScript, TensorFlow JS formatted models as well, and it also has a TensorFlow Lite model. So you get to play with 3 different models here: the TensorFlow Lite model, the TensorFlow JS model, and also the native TensorFlow saved model. So I think this is pretty cool, isn't it? Okay, enough for the demo, and I would now like to get back to the presentation. But if you have any questions up until this point, feel free to ask away.
I guess we don't have any questions so far.
Okay.
I guess it's pretty much clear to everyone.
Yeah. Cool. So yeah, this is the sort of repository of pre-trained state-of-the-art machine learning models that you get with TensorFlow Hub, and this is sort of a very condensed view of what TensorFlow Hub has to offer to the machine learning community. And let's now take a few use cases that are possible with TensorFlow Hub. This is by all means not an exhaustive list of possible use cases for TensorFlow Hub. This is just a few of them. So first is everyone's favorite, image classification. Here we are interested in just taking a pre-trained image classifier and run off-the-shelf inference. So let's see. So here's some code that would actually allow you to perform the image classification off the shelf with a pre-trained TensorFlow Hub model. So here's how you would initialize the URL to the image classification model that is already there on TensorFlow Hub. I'm using a MobileNet V2 model that's already pre-trained on the ImageNet dataset, and it's specifically there for performing off-the-shelf classification inference. So here's how you would load this TensorFlow Hub model into a Keras sequential flavored model. It has this handy hub.keras layer utility that sort of wraps the entire TensorFlow Hub model into a Keras model. And then you would typically, call the predict method on your newly constructed Keras model with the TensorFlow Hub pre-trained model as the base. And yeah, it's just 3 lines of code. And I hope this was able to, pique your excitement to try out TensorFlow Hub at some weekend. So image classification with transfer learning, that is also possible. And let's now see how. So same way, you would first, specify the model with which you would like to do the transfer learning, and transfer learning can be done in many different ways. For example, you would like to use a pre-trained ImageNet model to extract meaningful features from your own dataset, and then on those extracted features, you would typically want to, train a very shallow classifier. But on the other hand, you could also, fine tune a pre-trained ImageNet based classification model on your own dataset. That's also possible. So let's see how. So here I'm, providing the URL to the feature extractor, same model, but again, in this case, the classification here is sort of chopped off so that I only get the feature vector that I'm interested in. Then same way, I would create a Keras layer out of this feature extractor model, and then I'll append it to a very shallow classifier, which is just a few bunch of neurons. It's probably a very, it's not even a fully connected network. It's just a single dense layer which would take all the extracted features from my own dataset, and it would, yield out the predictions and stuff. And this feature extractor layer has this, handy trainable parameter. In case if you would like to fine tune on your own data set, then you would set this trainable parameter to true. Otherwise you can set it to false. By default, I guess the trainable parameter is always set to false. And then in the same way, you would compile your keras model and you would fit it just like that. It's merely 10 lines of code. So you see, if you do not have much of machine learning expertise, but if you would like to still try out state-of-the-art pre-trained models, TensorFlow Hub provides a very easy way to do that. So now, slightly more interesting is probably style transfer, because image classification can get sometimes boring. Style transfer is a cooler application of deep learning, I would say. So TensorFlow Hub provides, pre-trained style transfer models that sort of allows you to, take a natural scene image and, take also a style image to which you would like to see your image get transferred to. And TensorFlow Hub provides us with pre-trained models that can do that. So probably your content image is this dog, and you would like to see how this dog might look like if it was, painted in this sort of style image kind of manner. So here's all the code that you would need in order to yield a prediction like this. So the premise here is you would supply two images to your model. One, the content image, the image that on which you'd like to see the stylization, and another image that is known as the style image, which style you would like to see get transferred to your content image. That is the dog, that is the image of this dog in this case. So after you run this 4 lines of code, you would end up with an image like this. Pretty cool, right? Okay. So here's another cool example of generating, novel faces, and this human faces do not exist yet. And these images are generated by a generative model called generative adversarial networks. And TensorFlow Hub provides us with a number of different generative adversarial networks that are capable of doing this. So in this example, we are using a model by DeepMind, and not by DeepMind, sorry, it was provided by Google folks only. DeepMind is also a subsidiary of Google, but in this case, it was not DeepMind. So we are first again initializing our model. In this case, it's a progressive GAN. The specific architecture of the GAN is progressive GAN. We are first initializing this model. We are then taking a random vector from a normal distribution, and then we are applying that progressive GAN model on that particular vector sampled from a normal distribution. And here's all the code that you would need to visualize the results, and this is the face that you would get. And mind you, this face does not exist yet. This face is entirely generated by this progressive GAN model, which is already pre-trained and which is already provided to you via TensorFlow Hub. So here's another example, switching gears to natural language pricing. So text classification is a very popular use case of natural language pricing, among other use cases like text summarization, question answering, and so on. So for NLP based problems, transfer learning is also possible. Probably you would like to build a spam classifier where the problem statement goes like something: given an email, the task is to predict if the body of that email is spam or not. So if the body is kind of spammy in nature, it would end up in my spam folder, and if it's not, then it would straight go to my inbox. So yeah, again, we would take a similar kind of model that is able to extract meaningful features from texts and stuff. For NLP, it's typically known as text embeddings. And I would initialize that with the URL to the feature extractor model. I would then wrap that feature extractor as a keras layer. And in this case, I'm interested in fine tuning this model. That's why I'm setting the trainable parameter to true. Then I'm appending a classification head on top of the feature extraction layer. And in the same way, I'm compiling and fitting the model, just like the way you would compile or fit any other Keras model. So that's it. So there are other tasks that are possible with TensorFlow Hub, for example, enhanced super resolution, object detection, question answering, and more. Of course, I have provided links with which you can explore further if you are interested. And don't worry, I'll provide the entire deck that I just presented so that you can refer to it when it's needed. And you can publish your own models, and here are the guidelines if you are interested to publish your own models. Probably you have generated a state of the art model that is probably capable of doing a particular machine learning task, and probably if you are interested to share that model with the broad community, then you should definitely consider publishing that. And the entire deck is available at bit.ly/tf-hub, bit.ly/tf hub. And I'll let you folks note it down if you are interested. And I'll also pass this on to the organizer so that they can provide it to you. And thank you. I'll love to get connected to all of you. I'm on Twitter and my handle is Rising Sayak, RISING SAYAK. Thank you. And if you have any,
Yeah, Sayak, Anirudh is having a doubt. I'm unmuting him right now.
yep.
Okay. Yeah, Anirudh, you can ask away your doubt.
Hello, Sayak. Am I audible?
Yeah,
Yeah,
you are audible.
you are audible.
So nice to meet you, Sayak. So like I have been working with CNNs, like basic image classification. So for few hackathons, like I got some ideas like to use the object detection model, the YOLO V4 or V3. So like as a beginner, it's difficult for me like to train a model. So does TensorFlow Hub provides like pre-built model without any uh, image processing, like training on the data set you have?
Yeah, exactly. So all the models that we just saw on TensorFlow Hub, they are all pre-trained. They are ready to use. So if you see, if you search with object detection, uh, all of these models are based on object detection, and they also provide you, just as I demonstrated earlier, they also provide you with a handy collab notebook that demonstrates the model usage. So yeah, definitely try these things out.
So one more question, like what is the difference between this transfer learning and this TensorFlow Hub? Like both use the same principle of, I'm not sure,
No, no.
like.
TensorFlow Hub is sort of a platform that provides you with a collection of pre-trained models, and transfer learning is a general concept in machine learning. Let's say, uh, so the premise here is, if you have trained a huge, image classification model on a data set that is as huge as ImageNet, probably your model has learned about general features about a lot of images in general, and those features might be very useful for number of different things. Probably if you are interested in building a flower classification model, probably the features that would be highly useful would be probably edges, corners and things like that, the elements that are sort of very common in all the natural images. So in those cases you would like to utilize transfer learning in the first place, and based on the performance you would like to achieve, you can always draw trade-offs between fine tuning as opposed to just extracting features with a pre-trained model and then learning a classifier on top of the extracted features. So transfer learning is a general concept and TensorFlow Hub is a platform. So these two things are different.
So is there any model that detects objects through a thermal scan, like a person, figure, or like anything with a thermal scan going on?
I'm not sure about that, but the current object detection model that we are seeing is capable of doing things like this, like detecting persons, detecting parachutes and stuff. But for thermal based application that you just mentioned, you would probably need to fine tune on your own data set, and TensorFlow object detection API does provide you with the tool for training your own object detectors, rather fine tuning on pre-trained object detectors.
Okay, thanks, Ayak. It was very helpful. Thank you.
Yeah, cool. So just to give you a very quick example of how it may look like, Here's an example. So I have this end-to-end object detection in TensorFlow Lite repository. So you can use Colab for doing this. So this model, I trained the entire model in a Colab notebook, but this is also possible because my dataset is very, is very limited. But for general object detection based models, it won't be the case. I mean, you won't be able to train a very good object detection model if you have a very large enough data set. You would need to have access to a cluster of GPUs or something like that. So yeah, here I kind of trained a fruits detector, and this is also possible. I took a pre-trained model. The model was pre-trained on the Cocoa dataset, and I fine-tuned on this flowers on this fruits dataset that I collected from Kaggle. And yeah, as you can see, it's capable of detecting apples and stuff like that. So it's possible. It's possible for you to fine-tune a pre-trained model on your own datasets. The long story cut short here would be that.
Cool.
Okay. Thanks, Anirudh, for your question. Thanks, Sayak, for providing such a great insight over TensorFlow Hub and all the machine learning models that we talk about over here, object detection. And regarding the links, if you can share the links with us via email, or if you can just send share the links in the chat.
Yeah,
Whenever
I'm just gonna
whenever.
ping in the chat.
Okay, then whenever we roll out the the recording of this over YouTube, we'll just put everything in the description.
Yeah, I'm just doing it right. Yeah, I just chatted the link to my deck and also the repository that we are currently seeing. Yeah.
Sure, sure. Thanks a lot.
Yeah.
I guess we don't have any more questions.
Yeah. So if folks do
Yeah.
not have any more questions up until this point, they can always reach out to me via email. I also chatted my email ID, and all of my coordinates are available at sayak.dev. Sorry, sayak.dev. sayak.dev. Yeah. Feel free
It's
to
a very
connect to me at any point in time, and if you have any doubts that you are not feeling comfortable asking in front of everyone, just email it to me and we'll take it from there. No worries.
I guess everyone will gonna definitely use this
Yeah, sure.
opportunity. Yeah. Thanks, Sayak, for joining us. It has been a pleasure. It's like one of the one of the very good session in the open source domain of Hacktoberfest. Okay. Yeah. Just a second. Yeah. Sorry for the lighting and all. I'm
No, no.
sitting in a very dark environment and all. But yeah, thanks a lot. It has been very, it has been very intriguing. Like even I personally work with TensorFlow and PyTorch and on my own. So I used to go through your site. Like I have read a couple of your articles, and I've heard you before. If that was the actually the basic point that when we first reach out to you for Hackbout as a mentor. So that was because of that. So yeah, we are kind of following you at the Hack Club NMIT. We are
Okay.
reading out your articles. So yeah, you're doing a great job to the open source community, and just keep doing it, man.
Okay. Thank
Thanks
you.
a lot for joining, I guess. See you next time. Maybe
Yeah.
probably sooner that we'll have another session with you,
Yeah.
and
Sure.
maybe in the Hackbot 2.0. Eventually, we are taking our hackathon digital this year, so definitely you'll be able to make it.
Yeah.
So yeah, see you, man. Bye.
Yeah. Cool. Bye.
Take care.